The truth about black holes that no one tells you. We think of them as the monsters of the universe. These pockets of space so dense, with gravity so intense, that nothing, not even light itself, can get out. The ultimate cosmic abyss. At least, that's the story we've all been told. They star in our sci-fi nightmares as these ravenous celestial beasts, just prowling the galaxy, waiting to gobble up our planet. But what if almost everything you think you know about them is wrong? What if the real story is not only less terrifying, but 1,000 times more fascinating? Everyone pictures a black hole as a cosmic vacuum cleaner, just sucking up everything in its path. But what if I told you that if we swapped our sun right now with a black hole of the exact same mass, nothing would happen? Seriously, Earth's orbit wouldn't change one bit. All the planets would just keep circling that little dark spot in space like nothing was different. Because the truth is, black holes don't suck. The reality is far stranger, more complex, and frankly, more wonderful than you. Section 1. Debunking the cosmic vacuum cleaner. So, let's tackle that first big myth right away. The idea that black holes are cosmic vacuum cleaners is probably the biggest misunderstanding in all of astronomy. It looks great in a movie, but that's just not how gravity works. See, gravity all comes down to two things: mass and distance. Your weight on Earth is just a measure of the Earth's mass pulling on you from a certain distance. A black hole's gravity works the exact same way. The inescapable part only kicks in when you get unbelievably close, once you cross a very specific line in the sand called the event horizon. Think about our sun again. It's 1,000,000 times bigger than Earth, but we're in a perfectly stable orbit 93 million miles away. Now, imagine you could squish all of the sun's mass down into a ball just a few miles across. At that point, it becomes a black hole. Its mass is the same, only its size has changed. From our cozy spot, 93 million miles out, its gravitational pull on Earth would be identical. We wouldn't suddenly get yanked in. We'd all just keep orbiting like normal ... though it would get very, very cold. The only real difference is that you could get much, much closer to its center of mass before you hit a surface. It's only when you cross that threshold, the event horizon, that there's no going back. Beyond that point, gravity is so extreme that you'd need to travel faster than the speed of light to escape. And since nothing can do that, escape is impossible. So, black holes aren't hunters roaming the cosmos. They're incredibly passive. They just sit there, and you practically have to fly right into one. Section 2. The myth of the monolith. A universe of black holes. This brings us to the next myth. The idea that a black hole is a black hole. In reality, they come in a wild variety of sizes, and each one has its own incredible origin story. First, you've got your stellar mass black holes. These are the ghosts of giant stars. When a star way more massive than our sun runs out of fuel, its own weight crushes it. The core collapses, triggering a mind-blowing explosion called a supernova. What's left behind is that crushed core, a black hole maybe 10 to 20 times the mass of our sun. It's estimated there are about 100 million of these, just silently drifting through our own galaxy. Then you have the true giants, the kings of the cosmos, supermassive black holes. These are monsters millions, or even billions, of times more massive than our sun. We now think there is one of these titans sitting at the center of almost every big galaxy, including ours. At the heart of the Milky Way, 26,000 light-years from us, is Sagittarius A*, a supermassive black hole with a mass of 4 million suns. We know it's there because we can see stars whipping around it at insane speeds, orbiting a point of immense gravity that gives off no light. For a long time, scientists were baffled by the huge gap between the little stellar mass guys and the supermassive ones. But recently, we've been finding exciting new evidence for a missing link: intermediate mass black holes. Observations from telescopes like Hubble and our new gravitational wave detectors are spotting these middle weights, helping us piece together the puzzle of how some black holes grow to be so massive. Section 3. The myth of perfect blackness. So they aren't vacuum cleaners, and they come in different sizes. But at least they're black, right? I mean, it's in the name. Well, even that isn't quite the whole story. While the black hole itself is totally dark, the area right around it can be one of the brightest places in the entire universe. As gas, dust, and even whole stars get pulled toward a black hole, they don't just fall in. They get trapped in its gravity and start spiraling inward, forming a huge, flat structure called an accretion disk. The friction and intense gravity in this disk heat up all that material to millions of degrees, making it glow fiercely with everything from radio waves to X-rays. That is what you're actually seeing in that groundbreaking first picture of a black hole shadow from 2019. You aren't looking at the black hole. You're looking at the superheated plasma swirling around its event horizon, a brilliant ring of light framing the abyss. The black hole is just a dark silhouette in the middle of that celestial storm. And the Event Horizon Telescope team is now working on new ways to capture even more data, which will eventually let us see these violent environments in even greater detail. Section 4. The strangest truth. Black holes evaporate. This next myth we have to bust is probably the most fundamental. The idea that nothing can ever escape a black hole. For decades, that was considered absolute law. The event horizon was a one-way street. But then, one of the greatest minds in physics, Stephen Hawking, came along and flipped everything on its head. In 1974, Hawking blended Einstein's theory of gravity with the bizarre rules of quantum mechanics and reached a shocking conclusion. Black holes aren't completely black. They should, theoretically, glow ever so faintly, leaking a tiny trickle of particles that we now call Hawking radiation. Here's the simple version. Empty space isn't really empty. It's us fizzing with pairs of virtual particles that pop into existence for a split second and then cancel each other out. But if this happens right at the edge of an event horizon, one particle can fall in while the other one escapes. To an outsider, it looks like the black hole just spit out a particle. But here's the twist. To keep the universe's books balanced, the energy has to come from somewhere. The particle that fell in effectively had negative energy, which gets subtracted from the black hole's mass. This means, over almost unimaginable timescales, black holes can slowly lose mass, shrink, and eventually evaporate completely in a final burst of light. Now, don't wait up for it. For a sun-sized black hole, the evaporation time is a 1 with 64 zeros after it, trillions of times longer than the universe has even existed. But the idea itself is world-changing. Black holes aren't eternal prisons. They have a lifespan. They can have Section 5, the ultimate mystery, the singularity. We've busted the myths. We know they aren't vacuums. They come in different sizes. They're surrounded by brilliant light, and they can even fade away. But now we have to face the biggest, weirdest truth of them, all the thing hiding at the very heart of a black hole, the singularity. So what happens to everything that crosses the event horizon? According to Einstein's theory, it all gets crushed into a single point that is infinitely small and infinitely dense. That point is the singularity. It's not just a place with a lot of gravity. It's a place where gravity becomes infinite, where our understanding of space and time's warped into oblivion. It is the exact spot where our current laws of physics completely and utterly break down. The equations that describe our universe so beautifully just stop working. They spit out answers like infinity, which is basically a scientist's way of saying, we have no idea what's going on here. The singularity is where the two great pillars of modern science crash into each other. General relativity, our theory of the very big, and quantum mechanics, our theory of the very small. To really understand what a singularity is, we need a new theory, a theory of everything, that can finally unite the two. Some newer, highly speculative theories on the fringes of physics suggest the singularity might not be an end at all. Maybe it's a bridge to a white hole that spits all that matter back out somewhere else in another universe, or a different part of our own. This is just a theoretical possibility, but it shows that black holes aren't just objects. They are cosmic laboratories pushing the absolute limits of what we know. They are the place where known physics ends and the deepest mystery begins. The story of black holes is constantly being written, with every new discovery challenging what we thought we knew. If your mind is spinning with these cosmic questions, just like mine is, make sure you subscribe and hit that notification bell so you don't miss our next journey into the cosmos. And if this video bent your brain a little, give it a thumbs up and share it with someone who still thinks black holes just suck. So, the truth about black holes is far stranger than any science fiction story. They aren't cosmic monsters. They're a core part of how the universe grows and changes. They aren't simple vacuums, but complex engines of gravity that play by very specific rules. They're not perfectly black, but are surrounded by some of the most brilliant and violent light in the cosmos. And they're not eternal, but have a lifespan and will one day be gone. At their heart, they hold the key to the next great leap in our understanding of reality. They force us to admit that for everything we've learned, we are still just scratching the surface of space, time, and gravity. The black hole isn't just a point of no return. It's the frontier of human knowledge. A dark and beautiful mystery that dares us to look deeper, ask harder questions, and embrace the mind-bending truths the universe is waiting to show us.